Okay. So hi guys, welcome to this meetup event. So yeah, let me get started. So my name is Adebisi Ayomide, and I'm currently going to be hosting this event. And this is what we're going to be talking about from code to cloud, basically transitioning into cloud engineering and software architecture. So I'm just going to go through my slides now so we get started. Um, Give me a minute. Uh, okay, so we've waited 10 minutes for more people to join, but I guess people can join when we've started. So yeah, the topic for today is from code to cloud, basically transitioning into cloud engineering and cloud architecture, and it's hosted by Manchester Devops SRE Workshop, which is basically like a meetup channel in Manchester that deals with everything cloud and other things related. So this is our agenda for today. Um, I think we've probably lost like 12 minutes. We're going to be talking about the meetup group. We're going to talk about the speaker for today, and we have two important things that we need to go through, which is the topic one, which is basically how to transition from regular software engineering, so like a cloud software engineer or a software architect. Then we have about 15 minutes for questions. Then we have break where we play some games. Next and after that, we're going to do a project, and the project is going to be on AWS, Pulumi, and infrastructure as code with Pulumi. So we're going to talk about Pulumi, Terraform, why Terraform over Pulumi, the advantages, disadvantages, and things like that. And then we're going to do a project with a demo, see how Pulumi works and how to work with Pulumi at scale. After that, we're going to ask some questions, and we can put the questions on the chat. And after that, we basically go to like connect via LinkedIn and other things like that. So I would like to show how the chat works. So if you have a question during the Q&A section, you can just click on these activities, and this you can just basically ask a question. When it's time, you can just ask a question, and that handles. I'll just answer most of the questions from there. Okay, so yeah, let's get started. So Manchester DevOps SRE Workshops. So basically, what this meetup group is about is just to bring together professionals and enthusiasts, like share passion for DevOps automation, site reliability engineering, and software engineering. Basically, trying to bridge the gap between all these different things. And I will be the speaker for today. So I currently work as a senior site reliability engineer in a company in London. And previously, I've worked as a software engineer, an MLOps engineer, and a data scientist. Currently, I'm trying to build a startup that modernize the release of trained AI models for universities. And yeah, during my free time, I do a lot of mentoring, and I'm just going to try to go to my mentorship channel. So currently, I mentor a lot of people on software, DevOps engineering, and basically transitioning into cloud. And through this platform, a lot of startups reach out to re-architect their platforms and to give some kind of insights on that. So yeah, I've been doing this for over 2 years, the mentorship channel, and it has been okay. So let me go. Yeah, so we're going to have our icebreaker session. So if you can write your name on the chat, say what you do and where you're joining from, so we can kind of ease into this. So you can use the chat here. Just write your name, what you do, where you're joining from. Oh, hey Isaac. Hi, Abib. How you doing? Oh, hi, Fisayo. Mm. Oh, hey, Malcolm. Nice to meet you. Where are you in the UK? Oh, Edinburgh. Okay. That's Scotland, the big city. Oh, hi, Stephanie. Okay. Nice to meet everyone. So, oh, hi, Adebayo. Okay, you're trying to transition from product management to security product management. Yeah. Thank you very much, and I hope you find this session very useful. Okay. Um, yeah, we can just get started then. So the first topic we're going to be talking about is this is just going to be a talk. This is basically transitioning from software engineering to cloud software engineer or a solutions architect. So the reason for this topic or the thought process behind this topic is that I've seen a lot of software engineers get stuck just doing regular software engineering. So basically, I think that as a software engineer, sometimes your growth to become like a software architect or a solutions architect is kind of skewed based on the kind of company you've worked with. So if you work with a large scale company and you've been allowed to be involved in the life cycle of the full software solution, it's possibility your growth is faster. Imagine as a software engineer, you join a company where you're working with Docker, you're working in Kubernetes, you're troubleshooting Kubernetes, not really troubleshooting Kubernetes clusters, you probably understand how to deploy applications, then you can see how your knowledge gets like wider. So imagine you're a software engineer and you in your company you use AWS as the cloud. So you're using AWS or GCP as your cloud, then you probably start working with some cloud services, which starts increasing your knowledge across all these different domains. So you kind of learn the cloud without learn it on the job, basically. But most people don't really have this opportunity, so they just build regular software or microservice and kind of just pass it to the DevOps guys. So most times, how the code gets to production they don't really know. The full life cycle of the software solution is kind of hidden. So you see someone that is really good at writing Python or building a web application, but what they can just write is just code and not really code that can scale. And that is where some of the problem comes from. So if you join like a FANG company and you're trying to interview for bigger companies and they want you to architect a small solution, sometimes it gets really hard because you don't even understand the full life cycle of how that goes. Okay, so basically, like I said, transitioning from software engineering to like cloud software engineer or solutions architect. So let's just look at the differences between the two roles. For a cloud software engineer, you're probably looking as for a cloud engineer, not even cloud software engineer, because we're going to get there forward now. For a cloud engineer, you probably specialize in areas such as DevOps, you know a bit of security, and you know a bit of networking in the cloud. You're probably involved in like monitoring and maintenance of like the application, you know the request count of the application, you know how the load is getting into the application. You basically have like strategies for managing like outages and optimizing your AWS costs or your cloud costs. Sometimes, most times, the technical expertise include like knowledge of cloud platform, AWS as you, GCP, networking, some kind of Linux and scripting languages, Python or Bash. Cloud engineers will often communicate with like DevOps teams to and IT operations to implement and manage cloud solutions. So that's being a cloud engineer. A solutions architect is, I cannot say a much higher level, but you kind of see things at a much broader level because you're not just working on the cloud, you're basically architecting the full solution. So if you're getting into a startup or you're starting a startup, something, and you don't have someone to architect the solution, you kind of get into something they call is a pool of mud. We're going to see that in future. So basically, solutions architect basically stays on like design and strategy. They focus on designing comprehensive solutions. They create like high level architecture and blueprints. They have like a broad overview of the system. So they spend more time on strategies rather than implementation. Um, Basically, they do like solution design. So if you have, let's say, a a booking application now, you don't just build it normally. Most times, there are different strategies that you want to do it so that the application can scale. And in such a way that the booking application, let's say you're using Booking.com now, and you're using it from Nigeria, you're using it from the UK, you're using it from the US. Sometimes there are a lot of different country-based dynamics around it, whereby the solutions architect will have thought of before even designing the services. So, and also they focus more on cost management, keeping the costs low. So these are the issues I've seen that most people face. After speaking to a couple of people and actually mentoring a lot of people over the last couple of years, what I notice is that most people coming from a software engineering background or machine learning engineering background or something, they don't know what cloud is, or they just think cloud is S3, or maybe where you just store static files. Most people have like poor knowledge of like automation and concepts, how to automate a solution, how to make sure you don't touch anything. So imagine working as a mobile engineer, you've not worked with something like, let's say, fast lane before. So basically, Fastlane basically automates like the publishing of your application of your mobile app to App Store and also um, to this Google Play. Um, some of them have most people have little or no understanding of software concepts. When I say software concept, I mean the full software life cycle. What goes on? What are the different strategies? Basically, when you're designing a particular solution, how should you think about it? How should you approach it? Basically, extending solutions so that they are fully customizable. Some of them most people have little to no understanding of designing large-scale software systems. Most people have little to no understanding of system design, which I've seen a lot of people struggle with. Most people who have little to no understanding of software architecture patterns and style. So you're about to start a project now. What kind of software architecture pattern are you taking? Most people just jump to microservices. Are you designing microservices correctly, or are you just building a distributed monolithic application? So these are some of the problems that I've noticed, and also little to no understanding of designing data storage at global scale. And this is like a big problem I've seen, even with like cloud engineers, and also the software engineers also. So you're designing a data solution, which is like your backend of your application. How do you make sure you have availability, you have you're fully available? Can you make sure that you have like some kind of redundancy, you have like replicas and things like that? So these are some of the things I will talk about. So like I mentioned, a cloud software engineer, what does a cloud software engineer do? So basically, this is a software engineer that understands the cloud, basically, and basically harnesses the power of the cloud to design cloud native application, to implementing security best practices, to migrating in the cloud. So imagine you have like some of these old maybe .NET application, a legacy system of like, let's say 20, 30 years ago. And you need to do some lift and shift, basically move it to the cloud. Instead of you having it like on your servers locally as it runs in the data center. So that kind of lift and shift, how to break down that kind of system, bring it to the cloud, make sure make sure it's very cost effective, and also make sure that you are able to gain gain a lot from it. So and also optimize like the process and harness the power of the cloud. So like I said, the demand for cloud software engineers continues to grow as most companies move their infrastructure and applications to the cloud. So if you're joining a startup, some startups just they don't want to write the normal. You don't have to build different services, different microservices, and things like that. So they just use like API Gateway, Lambda, and S3, and with those three things, they're able to kickstart their solution. That's why you see like some startups are able to launch in like 3 months, while you would see some people building the solution for like a year because they need to look for different things. They don't have someone to architect the full solution of the MVC or of the MVP, and also to get that working. Okay, so yeah, so the cloud providers, as we know, the top three right now is AWS, Azure, and GCP. So I'm just going to try to explain this cloud native landscape. So the idea is that this might look like a lot, but most times it's just picking one of them and understanding the concepts, right? So basically, we're talking about infrastructure and the cloud is like AWS, Azure, Data Ocean, and the likes. We're talking about provisioning, which is like infrastructure as code. We're talking about Terraform, AWS Cloud Formation, Ansible, and these other ones. If you're thinking about cloud native storage for like storing this thing, you have like S3 and you have Minio and Leaf storage and the likes. Container runtime, which is like for Dockerizing application. No, containerizing application because that's too specific to Docker. And you can use like Docker, Container D, and basically different things like that. Orchestration management, this is where Kubernetes and like Docker Swarm comes into play. It's console for like service discovery and but most of these cloud services have service discovery. ECS has it, Kubernetes has it internally. Like I said, sometimes you just need to pick one tool and start with it. Let's say you're doing CI/CD now, you can start with GitHub Actions. Let's say you want to learn the something on the cloud, you can start with AWS. And basically, the knowledge is transferable across these different things. So it's like you write Python. Basically, you should be able to write Node, but because you understand the concepts of if-else, the different approaches, you just need to check how this is done for this. So this looks like a lot, but picking one and getting started with it to understand the core concepts makes it easier because then you can make it, the knowledge is transferable across every other one. Yeah, so I'm going to talk about the most important qualities in designing large-scale systems. So let's say you're trying to design a system that you want to make sure can scale. The most important qualities are performance, scalability, availability, fault tolerance, and disaster recovery. So you're talking about performance now, you're talking about request response time. So basically, for your whole application or for your whole software, you want to make sure that you are able to set a particular time. So let's say you have this thing on your application whereby you want to set it that no requests, basically like setting a limit for the company that no requests and response, no request response time like call and return should take maybe less than a second or something milliseconds. So most companies are able to set that thresholds and make sure their APIs are able to get to that or towards that. Scalability, make sure that your application is scalable. Mostly, this is mostly done if your application is kind of stateless, which means it does not store any state locally. So if you're using like a server, you can just like duplicate it multiple times. Availability, making sure that your software is always highly available, and you have failover. You have basically like maybe like some kind of blue-green approach. And also, if you're talking about scalability, also you want to use like a load balancer in front of, let's say, no matter how many servers you want to have. So the servers can be scaling up and scaling down based on need. So basically, you can scale up based on how people are using the application. You can scale up based on time. Let's say you know that a lot of people are using, let's say, Amazon now, within 7 a.m. to 7 p.m. Let's say a lot of people are shopping on that. You can have like a scheduled scaling to scale that up to a particular amount to work with your application. And after that, kind of reduce it based on like the load and stuff. So you're talking about fault tolerance. You're talking about something like active. So you might active, passive. So what this means is basically having like a disaster recovery region. So if you deploy an application and you have it on your startup or whatever software solution you've made, you have it running, and basically the fault tolerance is that let's say something, basically fault tolerance and disaster recovery. Let's say something let's say the application goes down or something happens, or let's say that particular region on AWS goes down. You don't want your application to go down so you don't lose money. So you probably like have like an active standby, maybe like a smaller scale of your application running on a disaster recovery region whereby traffic starts going to. And you can do this on like the DNS layer and manage it from there. So these are some of the very important qualities I've seen in designing large scale systems. Yeah, so we're talking about data storage at global scale now. So yeah. What are the types of databases that we have? We have like relational, non-relational databases. So relational databases is like ACID transaction, which has this like atomicity, consistency, isolation, and like durability. So atomicity is that if you're writing to a relational database, it's either it gets completed or it doesn't. There's no partial write. Once it's either you write or you don't, which is like more desirable. That's why a lot of people use this for like financial applications. So it's either you've completed the transfer or you've not. You get, so there's no middle state. Consistency means that the data will be consistent. Basically, isolation is that when something is happening, it happens once. There's no, it happens and comes back. There's no state whereby you've moved the money to this second account on your DB, but it's still existing on this first account. So it has to go or it doesn't. Then there's durability. What this means is that the final state will always pass it to the DB. For non-relational databases, this is more flexible. This is like MongoDB, Cassandra. And there are ways to improve performance and availability and scalability of databases, which is where a lot of people kind of fail, because one has to do with like the software engineers. One, sometimes they have like data engineers in between, and sometimes the DevOps guys or the cloud engineers. So what happens here is there are different ways to improve performance and availability and scalability of your database. So one is like database indexing. So basically, if you have like a large table and you're calling and you're trying to search for something based on a particular column, it's best you index that column. So I've been in a situation whereby an RDS database was very slow when you try to call it, when you try to basically run SQL queries on it. And most people don't know how to, if you ask most people how to solve that kind of situation, they just tell you create indexes. And basically, when you're creating indexes, you don't just fix the issue by creating indexes. You need to at least analyze the issue here. So that's why there's something called explain analyze. So explain analyze basically gives you the data, makes you understand exactly what's going on in that particular table and why it is slow. Something called explain analyze. Let me see if I can show it here. Explain analyze. So yeah, explain analyze basically gives you like this query plan where you can see, and there are some visualization tools which yeah, there's some visualization with basically, yeah, you're able to like put your plan on the query. Your plan is the aspect of explain analyze, and then there's a query, and this kind of gives you like a visualization of exactly what's happening. Yeah. Okay. So also we're talking about the next thing after to improve like your availability and scalability of a database is replication. Basically, having a rich replica. So if you are hosting a database locally, sometimes you can have like a slave master relationship. So that's basically like have like a rich replica. If you're using like a cloud, you want to have a rich replica of your databases also running somewhere. So the next thing is database partitioning and database sharding. Sharding is a word I've seen people throw around anywhere, like scatteredly, or people just throw sharding around. You ask them, oh, how can I do this sharding? Then you ask them, how do you shard a database table? Most people have asked those questions, don't really know how to shard, but they just like throwing the word sharding, caching, the fancy words anyway. So if you want to like shard your database, the high concept is you are basically let's say you have like a distributed database using something like Cassandra, and you want to shard the database. So basically, the different database nodes will actually be holding the different it's a different data. So based on your particular data that you have, you can shard it based on the ID or the name of a particular key coming into the DB. So once you're able to like shard that particular have like your hashing algorithm, so hash the key wherever it's coming, you can basically send this to like the different nodes of the database, and this allows you to hold like bigger amount of data instead of just like replication. So yeah, if people can read more about how to shard databases, it's somewhat of a complex process, but it's easy to do. The next thing we're going to talk about is basically just this CAP theorem. So CAP theorem is just a weird thing about databases whereby there's a rule that says that you cannot have all three of this in any database. So you see this database that we see here, like Postgres, Cassandra, Mongo, Redis. Then there's no database that has three of them. You have to let one go. So it's either you have like CP, which is like there's some risk of some data becoming unavailable, which is like example MongoDB, Memcache, Bigtable, Redis, or you have like PAP, which is like partition tolerance and availability, whereby sometimes there might be inconsistent data. So data is somewhere and it's not somewhere because it's partitioned. Or CA, whereby you have consistency and availability, and you might some network problem might stop the system and things like that. So the CAP theorem is it's kind of weird. There's a particular data company I spoke to recently. I said they've done this. I think is Vector Astra. Let me see. Yeah, there was this company that said they solved the problem around this. I mean, I don't believe them, but because it just said they've just I think they've just suppressed the problem in one particular one lesser. So I tried their vector search and some things. It was nice. So the next thing we're going to talk about is like software architecture patterns. So for software architecture patterns, we have three, not necessarily three, but there are three most important ones or that are widely known. Multi-tier architecture, you must have known this one as three-tier architecture, microservice architecture, and event-driven architecture. A lot of people don't know or don't use event-driven. I probably have never used it before, but yeah, this is also a really good one. So let me see if I can explain it some more. Okay. So for multi-tier architecture now, it has basically three different layers. There's the application presentation layer, which is this. The application layer, which is like the logic layer, and this is the data layer. So imagine this is React, think, or like a front-end framework, and this is like your APIs, wherever you're writing your APIs in. and this is like a database, whatever database you're using. So basically the application layer, the business layer, or the logic layer, and also the data layer. So there's some advantages and disadvantages to this. This is like the oldest, and this seems to work for like a lot of things. You get, but basically this just allows you to have like a monolithic application, which is the application is coupled into one, which is like that's just you don't have like microservices kind of thing, and everything is just the same thing. Sometimes what this leads to is having like a complex code base here, and this mostly works, especially for like startups, because for your business logic, if you want to scale, you just need to put a load balancer in front of this and scale the number of APIs or whatever servers you have here. I think is horizontally, and basically this scenario works. But some of the cons is that you have like a complex code base, some kind of single point of failure, because if this data thing is, if something happens to this particular data layer or it's not accessible, your application is down. It's not like some parts is working, some parts is not working. Everything is like, down. The next one is microservice architecture. So for microservice architecture, basically you have like the applications broken down. You can have like a user service, the session service, the maybe event service, or and something else here. So each of these can be written in like different languages. You can use Python here, you can use Node.js here, you can use maybe Kotlin or Flutter if you if you want to write backend with Flutter. But yeah, you can use something here and do something else here. And basically all these databases, all these microservices, they basically have their own databases. But the problem that most people do here is that they they think they're building microservices and they end up building, I don't know, a distributed monolithic application. Basically, like this, like 20 places. That's what they end up building, which is it doesn't make sense. So the pros are this can be managed independently, and you can do this. But the idea is that once you do this wrong, you still fall into the same problem you have here, which doesn't make sense. So and sometimes if you're doing like a microservice architecture, designing it correctly is has to be done, because if you don't break down the microservices into exactly what you're doing and making them like kind of isolated, and I mean there will be some kind of shared data across them, but not so much. I remember I was working with like a company that had like a user service and a session service, and for the front end, they were saying they could not get. So there was a page on the front end that required something from the user and this service to show on the same page. And the person was saying it was like not possible, which means that the system was not architected correctly from beginning, and it was just there. Sometimes if you don't architect this well, you're falling into like a big ball of mud, and we can check what that is. Big ball of mud architecture. So you can see like images. Yeah. So as something as rubbish as this. So let me see if there's like a clear. Yeah, so basically a big ball of mud. So let's say you have like let me see if I can zoom this here. Yeah, you have like a microservice talking to another microservice and talking to different ones, and before you know it's just yeah, you're just using like distributed monolithic applications that is going to give you so much problems, because you're going to need to like talk to 5 microservices before you can do something, whereby a microservice is supposed to do like a particular function without needing help of the others. So the big ball of mud can be something easy to fall into if you are not careful. So let me see if I can open this, open image new tab. Yeah, something like this. This is even still like broken down, but imagine the interdependency, just so much. Anyway, this is a very nice one that I've been using for a while now, which is like event-driven microservice architecture. More like you don't need to call the service directly. You basically have like a message broker. This can be Kafka. I think Redis has Redis events. This can be MSK. This can be SQS. So basically, you have a service and you just throw an event here. So each of these microservices are subscribers and producers. So they can produce event and they can listen for events. So you just need to just send an order event, the order service or whatever event, whatever service that is listening for that event picks it up. This can send another event, whatever service is listening for it picks it up. So there is no a request response time. And this basically works correctly. So imagine you have like a bank app that's like a front end service and an account service. So your bank app, you just basically send money. You're not probably waiting for anything, and that basically goes through and the event listening for it, let's say the credit event, picks it up and basically send an email to whoever needed that particular cash. This is how it is like done on the cloud. So if you're familiar with AWS, just imagine these Lambda functions are like services. Man, this is like Kubernetes, this is like a Lambda function, this can be like some API, this can be something else. And the event routers can be SQS, SNS, MSK, this is like managed Kafka service, event bridge, maybe a step function. And from there, you're able to like build your application without any extra stuff. So the next thing is that there's some large architectural building blocks. If you're building large scale systems, DNS, a lot of people have probably heard of DNS, load balancer, message brokers, which is what we just talked about, CDN and API gateway. So let me see if I can explain some of them. For the DNS is just domain name service, which is like the phone book of the internet. That's basically what it is. So like a load balancer basically allows you to balance traffic from a single point to whatever amount of servers you have. So if you have like 200 servers, you just connect from like a single entry, and that basically sends traffic to the different kind of things. With the DNS, you can do something like geolocation routing, which is maybe when some users access your application, you want to redirect them somewhere else, or you want to redirect them to the German version of your application. So imagine something like you visit google.com and Google sends you to google.co.uk, or you visit google.com and it takes you to google.ng in Nigeria or something. So this is all done from like the DNS perspective, and you can do it from the load balancer also, but from the DNS perspective, it's much easier. For the message brokers, these are the stuff we just talked about, Kafka and the like. There's something called CDN, Content Delivery Network. So for CDN, you are probably once you like your React application or your single page application that has like HTML page, JavaScript styles and videos and things like that. Most times when you use a CDN, it allows your application to load faster because your content is cached in an edge location, and that makes the application load faster and makes it easier. So for API gateway, API gateway is more like when you're building something like this, most times your application is calling your React application or whatever application you have is calling all the different services. So this application needs to know about the endpoint of this service, the endpoint of this service, the endpoint of this one, the endpoint of this one, and to just keep like calling all the different services, which means on this application, you're probably storing the base endpoints for all these different microservices, which does not give your application like a single entry. So imagine this now. Imagine you have this as your authentication service. What this means is that you have to call authentication service to get a token before you can call this every time. So which does not just allow you to go into like an API gateway part. Mine was an API gateway here, and from there you're able to reach out to these different applications. I think I did yeah, I did a service here. So imagine this now. You want to reach the front end, you just this. You have to implement kind of an authentication layer on all four of this, right? Which doesn't make sense because every time you're calling a service, you need to check if you have a token that's valid everywhere. And this is like, let's say you have like a front end here. But if you're using an API gateway can be here. You can put your authentication on the API gateway, and from there, you're able to like route traffic. So this allows this gives you some advantages because you can do like request routing, you can do you can cache some kind of caching here, and you can do some kind of monitoring and alerting here. You have like a single point of entry into your application. Be like API gateway and maybe like a load balancer, then things like that. But this is just way better than this. Instead of having to put authentication layer and copy the code across everything. If something changes the authentication here, it's you might not be able to access the service and you'll be able to access the others. So because it's not like a centralized place for this. Let's move forward. Yeah, so this is the same thing I showed. You have like a web or your mobile application reaching out to the API gateway and then calling the different things. The API gateway is calling your catalog service. You can call your shopping cart service. You can call your discount service. You can call your audience service. Instead of you using your web application and calling them directly. So this is what the microservice architecture is supposed to be, not the ball of mod stuff where you're calling this is calling this is reaching out to this, then sending you where you get a response back from this. So sometimes you have to call this, then this calls the shopping cart, then check something, then get the data from here before it trails down and come back here, and you're just like increasing latency in your application. So the API gateway layer is always important to manage all those things. So most people have seen build this with like what's the name, a GraphQL. So it's like a GraphQL layer, and this basically calls like REST in the background or in the backend. It's a way to handle it. Okay, yeah, this is something I put on the group. Based on some of the things we've talked about and stuff. I want to see if so you can see this on the slide. Anyway, the slides are here. So if you're up to the task, you can discuss your approach on the Slack channel, basically by just clicking this. So if you're up to the task, try to design a URL shortener service. Think about the things we've talked about here. Try to see how your application can scale, and then you can design it and just drop your design on the chats on the Slack channel anytime. So questions. So we have some minutes for questions. Is there we can use the questions icon here to the Q&A section to just like ask questions. So if you have a question, you can just ask now. We have about 15 minutes for the question. Okay, for an e-commerce solution built by a startup, what would you recommend, microservice or monolithic? So, like I said, sometimes this decision, okay, you've already said that this decision comes with like budgets and things like that. So if you are starting on this with like a budget and you're trying to build a solution for like an e-commerce, the best way to do this, because a lot of e-commerce exist and don't really kickstart. So most time what you want to do is what you want to do here is build this like monolithic approach, get your markets, users or customers, and then build it in like the microservices approach if you start getting users. Because the problem now is there's some people that can just run their solution on like one instance or deploy the solution on one instance. But at the beginning, they started with like microservices, started building so many unnecessary complex solutions, and it wouldn't make sense. Okay, what career advice will you give to a product manager transitioning to security? So I think the idea of this, if you're moving into product management, security product management, then you probably need to get some basic understanding of what the cloud is about. You need to at least understand, be able to speak some of these different cloud concepts, know what DNS is, know what is possible and what is not possible in the cloud. So if you're going into like a security cloud, something you want to do some kind of small security training and get understanding on basically how all these different things works. So getting the understanding will allow you to be able to even manage people. So that's why you see people that you see product managers managing, let's say, some teams, but they don't even like understand like basic concepts. Okay, so um, yeah, a bit in cloud architecture, what are the various indices that inform the architecture design? The application load balancer, should applications use DynamoDB. Yeah, actually, this depends on your approach or what your application needs right now. So basically, if you are trying to build something, you probably have the solution, not like a solution, but you probably know exactly what you want to build. Have your like your requirements and things like that. So based on your requirements, you can start designing based on that. So imagine you want to imagine you have an application that just maybe you have just 20 or you have like 1,000 users per day. Imagine, depending on the amount of traffic coming to your site, imagine depending on the amount of time people spend on your site, the amount of processing power your particular application is doing. So those metrics are what you're going to use to know if you need a load balancer, if you need to scale, or if you don't need to scale. So the problem is the idea is to grow with your application. So have an approach that can grow with your application and not just over architect from beginning. So should all applications use DynamoDB? No, DynamoDB is a NoSQL database, a non-relational database. So depending on your use case, you can either use like a relational database or not. So if your use case is not like unstructured and things like that, you're doing like a let's say a what's the name of this stuff? Like a banking application now, you want to make sure you're using a database that is ACID compliant. consistency, the atomicity, and the likes. So what do you consider when putting a cloud architecture design? So basically, you just need to consider how the application would scale. You need to consider your use case right now. You need to consider cost optimization and basically things that you need to be able to get yourself moving and to be able to scale in future. So the idea is always start small and leave room for you to be able to scale. Yeah. So for Isaac, you're saying question is to know when to choose the right architecture. You get the cloud does this. How the advancement resource improvements, right? Cool. So some of the based on your question here, the idea is to before you can be able to understand what the right tools are, you probably need to know what is available. You get sometimes you're using something like Kafka, you want to maybe host your Kafka solution, but that can be expensive and hard to manage. Most people managing Kafka themselves. So the idea is to architect this, and it only comes with like more experience reading about different architecture patterns. Because the idea is that most companies, like big companies, they face some of these problems before, and some of them they have it published. So they build some kind of solutions, and the software has gotten to a particular part that it cannot scale anymore. Like there's really nothing they can do. So I did something for a startup some time back, and their system was microservice, but it was just like the startup could basically run on like two EC2 instances and save a lot of cost. But they've already slammed Kubernetes, Docker, so many things on it, which just overcomplicated the solution. Okay. So when you say microservices are not well architected, um, that's because I showed this big ball of mud whereby you build a microservice architecture and basically uh, each for microservices, each function or each service is supposed to do a particular function. Basically, if something is managing like the user, another one is managing like the events or something, one is managing like sessions. There's really no way you can separate it, but most of them should have like clear separation of concerns. If you have like an email service, it should just be email. You should not have like an email service that authenticates also. You should not have like an email service that does something else. So if you call the email service, you just know you're calling the email service and that's it. But what most people end up doing is that they call the email service, then the email service probably checks the user to see if the user has if the user maybe subscribes to a particular email, and then from there it comes back and then makes the request. And that shouldn't be like that. Instead of you going up and down, you can just architect the email service to be able to do the email function. So what this means is maybe from your request, you're actually sending if the user is available to send that particular thing or not. Instead of the email service reaching out like the user service to find out another information before even doing anything. So at some time, you just have like microservices talking to each other after just one request. There was a system I saw whereby when you call one endpoint, that endpoint calls 7 microservices, and that made their platform slow. So before the endpoint can give you like a request, it reaches like 7 different microservices before coming back, which is not what you want to achieve. Okay, like I said, and if you have like an API gateway in front of it, it makes things easier. So you can do that from that side. In what way can a database be made more secure apart from using passwords? So if you're talking about depending on the kind of database, you want to have like TLS enabled in transit and also at rest. If you're doing this also, you want to maybe have like some certificates. Make sure that the the database is able to like validate the certificates before you're able to access the database at all. So and if you're using like a database online or maybe like RDS or something, basically close up unnecessary access to the database. Make sure the networking towards the database is just coming from where you need it, and isolate the security group basically from the networking part, and also certificates and keys. That's what you can use to do this. Okay. You said the challenge you have with microservices, how you can distinguish between distributed monolithic and microservice. Okay. So how do you distinguish between distributed monolithic application and microservices? And I think all this actually boils down to the architecture and how this is architected. So if this is not designed properly, you're going to fall into this approach whereby you're calling different different things at once. Okay, you said you've seen some distributed services that may have some event-driven communication, even at different data stores. Like I said, this just depends on the way you. So even if they have different data stores, if the data is if the microservices are not broken down in such a way that they have like a separation of concern, or there's no way you can have like full separation of concern, but if there's a way that you can break this down into in such a way that you reduce the number of times or the need for a microservice to reach out to another to perform its own function well, then uh, then that's the way to go. Okay, regarding the concepts of comprehensive microservices, should each microservice have its own database or is access from? No, each microservice must have their own database. Um, Having like a central database is probably not microservice again, because that then brings up to like the single point of failure I talked about in the monolithic approach. The problem with the monolithic approach was that you had like a single point of failure on the database. But now, if you're bringing that into microservice, then you're having the same problem again. So you do not want to have that shared, shared database. And I think that's why most people are going through the approach of using like monorepos. So basically, like they have a repository that has like different services, and they're able to like share code across instead of copying the code multiple times. Instead of copying like based on what I showed here, instead of copying the authentication layer here, where was it? I think I showed it here. Yeah, instead of copying the authentication layer, I showed it here. Instead of copying this authentication layer multiple times and having the code duplicated, sometimes people use monorepos and they're able to like reach out to this to get it done. Yeah, so let me come back here. So yeah, I'm going to share this. I'll search for it now and try to share this also. Yeah, so I think yeah, that's all for the questions. And yeah, so the next thing would be to play some game. So I was less busy yesterday and I was trying to look for some engaging games to do that we can play here, but I couldn't find any. So I had to build one myself. I used S3 and basic HTML. So I don't know if you can hear me, or if you're ready, can you please like just thumbs up or something? I think this does issue. Yeah. So I'm going to put a link on the chat. What I'm just going to explain what the link does. On the link, you just need to put your email. And the first 3 people, so I don't save people data. The first 3 people to send the request to that, first 3 people to send the request to that particular thing. So first 3 people to send a request on that on the application would get like £20 voucher at the end of today. So I'm just going to send £20 Amazon voucher to each person. So I'm copying the link now and I'm going to paste it. So that's be like fastest fingers. So first 3 people to put their names on the link. First 3 people to the emails. So I've used something with SRE and HTML and JavaScript and DynamoDB. So we would see the winners here. Sortable items. Oh, okay. So these are our winners. Sorry, if you're still trying, there's no way to get into it again. You should be seeing the winners and sorry. Let me see. Okay, so the winners we've gotten this person. I hope the emails are correct. This person, and this. So I'll send like Amazon vouchers to these emails and send the gifts. So yeah, this solution is done now. Anyway, congrats to the winners. Yeah, sorry for your network provider that didn't send. Well, yeah, congrats to the 3 winners, and yeah, let me check them again. Ima Ogre Shileshion and this. So I'll send Amazon vouchers in £20, and yes. So we can take like a 5 minutes break. The next part is basically a solution with infrastructure as code using Pulumi. And this is Pulumi and Python. So if you've heard of infrastructure as code before, you're probably thinking of Terraform and things like that. But this would show us how to do the same thing with Pulumi. So let's get like 5 minutes. We'll start again by we'll start this by 11:20. So oh, Emmanuel, congrats to you. So we can start again by 11:20. So before we start, in case anyone is interested in the way I did this or the way I built this is basically this was just something I quickly did with in case you've worked with Lambda before. So just something I quickly did with Lambda. So Lambda now has something called what's the name? Function URL, which is this. So what that means is that you don't need to put an API gateway on top Lambda to get like an endpoint to call. So what I just did is Let me see if I can zoom here a bit. What I just did is, and this can be used like for like ML use case. So if I have like a, I think someone says she's a machine learning engineer. So one thing you can do here is, let's say you have like your, and I did this, but I can't show the code now. So let's say you have like your Pico file or your H5 file from your like, trained machine learning model, and you basically want to do like Pico.load, basically loading the machine learning model and serve it. I um sorry, give me um I'm trying to see if I can. Okay, yeah, additionally, I think we can unmute and talk now.
Sorry, that was a mistake.
Oh, okay, no problem. So I think instead of the chat, we can just ask questions more now. Um, anyway, let me just continue explaining this. I think I have this. I think I had this on my repository somewhere. No. Um, this. So let's say this is just like a basic machine learning model. Let's say you train a machine learning model that can can train using like random forest classifier, and you've gotten like the model out. Or is that also serverless application? This, yeah. So if you can see what I'm doing here, basically I'm just I'm loading in the model using this pico.load. I'm loading it from S3 where it was downloaded from, and then using the loaded model to make like a prediction. So this was the output. Where do I have it? Screenshots. Um, yeah, so this was the architecture. The front end was in Django and Python. I had like an email service, an API service, and a couple of these. I had like a Docker container with like a base image of pandas and all this ML. And that Docker container is the base for the Lambda. And from there, you can easily like build like a full like ML solution across this. So I think we have 1 more minute before we continue. Just to come here. So congrats to the winners again. Well, let's get started. So like now we're going to be using AWS and Pulumi. Um, so if you've ever worked with AWS before, you know how to. You can just check Google on how to set up your AWS locally. You can just like AWS configure and do this. But if you've connected, you can have like you can check that you're connected at least. Or AWS STS gets color identity. I know that you're logged in. So this is my user Al-Sahim. Okay. Anyway, so let's get started. So what is infrastructure as code? Infrastructure as code is the ability to provision and support your computing infrastructure, whether on AWS, Azure, or GCP, and any application requirements that has like database components, operating system, storage, and things like that. Instead of you doing it like going to the UI and clicking, can basically use infrastructure as code to to manage it. The benefits of infrastructure as code is are easily duplicating an environment, reduce configuration errors, iterate on best practice environments. So now Pulumi, which is like a subject of concern. What is Pulumi? Pulumi is an infrastructure as code tool which basically allows developers to deploy and manage cloud solutions using familiar programming languages. So instead of you writing Terraform, which is like another ecosystem you need to learn, and then Terraform has some very weird functions, basically interpolation and weird things like that. So you can just use Python with Pulumi and write it like you're writing like a normal code, which basically allows you to do a lot of things you can do in programming languages. If you're doing if else, you're doing something, it just makes more sense. You don't have to be doing it feels more familiar. Some of the advantages are like programming language support, multi-cloud support, rich ecosystem and libraries, and like secrets management. So let's talk about the other infrastructure as code. So apart from Pulumi, there's like Terraform, there's AWS CDK, Cloud Development Kit. So the idea now is that Terraform has been, everybody has been using Terraform for a while. And because people have started moving to Pulumi and CDK because they want to write like actual code with programming languages, Terraform did something called CDK TF. So I've been using this for like a year plus now, and it's very sweet. So imagine there's a sample Terraform code here. I'm using this from my friend John. So he has there was a static website, something with AWS, basically having like AWS and AWS creating buckets and CloudFront origin and things like that. So I'm using that. CDKTF, I think is something. Okay, I didn't write this. CDKTF, which is like CDK for Terraform. It's like basically you can write your Terraform code now, but as code. So this works with like Terraform workspaces and every other thing. So now you can write it as code. It's like a sample on the CDK repository. And this is nice because now you can have like published npm packages that or something they call construct instead of you having like modules. So this is something I did with AWS CDK. Yeah, so like 2 years ago, and I basically built a sample project with AWS CDK. So basically this. So some of the other infrastructure as code tools. Let me see. There's one called this one are not tools, but you can use like CloudFormation, AWS CloudFormation, Azure ARM templates. I think GCP also has theirs. Pulumi versus Terraform. There's a Terraform has like some sort of complexity whereby you need to manage your state using you need to learn this HashiCorp configuration language, which is sweet but annoying to learn. You have to handle interpolation of functions specific to Terraform, which can be less intuitive. So if you're a developer and you're seeing so many weird things, that's why nobody just wants to go there. With like Pulumi simplicity, you can this uses like a lot of programming languages. You can use Java, Python, JavaScript, anything, and it's more easier and easy to read. So there's like a demo that I'm going to do now. Basically, these are the goals of the demo: creating a Pulumi project, important components of Pulumi, deploying resources to Pulumi. Ideal way to structure a Pulumi project. This is like my personal opinion. Storing config secret Pulumi and migrating from Terraform to Pulumi. So yeah, I'll just come here. So I started some demo already, and this is what I've seen being done in like some Fortune 500 companies and basically people that have like very good understanding of this. So with Pulumi, if you can go to Pulumi get started and basically start a new Pulumi project. The command is Pulumi new. If you want to should I say close your application or make it use like a cloud secret, you can use like AWS KMS as the secrets manager. You can use Azure Key Vault, GCP KMS. You can use if you have like a template on a particular location, like a GitHub, you can use that as the template of your Pulumi project. But anyway, I've created some, but I would create one now again. So cd database Pulumi. So for Pulumi now, same way you've done with like Terraform, you want to store your state in the backend, which is like S3 or Azure containers, or what's the name, or GCP Cloud Bucket. So basically, I'm just going to log into my state because this is what I want to use as my state file. And then I can, so I'm in the database folder here. So this is my own personal opinion that when you're starting a Pulumi project, or when you're starting infrastructure generally, you want to break down some important components. Like if you're having things relating to IAM and users and question of users and question of policies, you want to just keep this out. This is just like a personal opinion. You don't just lump everything together. For database, we're creating Aurora, things like that. You can keep it like out of it, which is which doesn't go with like the typical infrastructure. So for the typical infrastructure now, you can have like S3 bucket, SQS, SNS, basically I don't even think you should put Lambda here, but basically other services can just like come up from here, CloudFront. And if you're managing DNS also, you should have like a DNS project and kind of manage it from there. You can't keep them isolated. It's personal opinion, but it just allows isolation of concerns. So anyway, I'm going to start a project in this. So I'll just go Pulumi new AWS Python. So it's asking me for the name of the project. It's a database. So database. Let's give it a name. Project to manage databases. Basically, this has concept of stacks. And what is a stack in Pulumi? A stack is basically like you've used Terraform. I can see like your Terraform states. But instead of you having like the state for your dev, the state for your staging, the state for different things. So the stack is what links to the states. So my stack name, I'm using it as dev. So this creates a Pulumi project. So I'm just going to put enter. So because I've specified this as AWS Python, if you're using GCP, you can do GCP Python or AWS TypeScript, no matter how you want to write it. So it's asking me what I want to use for the installation of the dependencies. So I say I want to use pip. So this is my region. So what Pulumi does is that Pulumi creates a virtual environment and installs the things needed for that particular template I've selected for AWS and for Python. So I don't need to go and add any extra installations except I need something extra. So this installs all these things and creates a virtual environment, as you can see in this project. So let's wait for it to complete. So something I did here, because I have like different projects, I did various approaches into how to like structure your Pulumi project. So like this now, the command for using Terraform, I want to do like Terraform plan. The command here is Pulumi preview. So basically, we can preview exactly what the infrastructure wants to deploy. But right now, there's nothing I have because this creates like a main.py. Okay, this is trying to create an S3 bucket. So you can see this is doing like this is a sample code, a demo code. So it's telling me, I'm saying Pulumi preview. So preview means tell me what it wants to do. So it's previewing and it's telling me that it's going to create an S3 bucket named my bucket, but I do not want that. So I'm just going to clear it out. So you can see the way Pulumi creates like a main.py, but you don't want to end up writing all your code in this main.py because it becomes so long. This is where you can get more idea into like the power of Python or the power of the programming language you're using. You can create a file somewhere here, import it into the main.py, and basically run the file. Have like your own structure. You can create an SRC folder, have so many things, and just initialize it in the main.py, and that basically creates like the full stack. So I'm not going to do this for now because I don't want to create an S3 bucket or whatever. I'm going to go into IAM, which is basically the one I've prepared. So close this. Let me go to the IAM now. So for IAM, you can see that the only thing I have here is need someone raise their hands. Or we can answer the questions when we get to the end. Or let me just continue. So we have this user group management, and the main.py is basically what Pulumi calls. So you can see me. What I did here is I just created a folder. I created a new file. I created a class called user group management. So what I'm doing here is for people that write Python, I have like an init class, and this is similar to like JS also. I have like a create group, which basically uses this Pulumi AWS SDK that has gotten installed. This is the SDK here, the documentation of the SDK. This is it in Python. This is in TypeScript, in Python, in Go, in C#, in Java. So let's say I'm doing something regards S3. And let's search for S3 here. From S3, I can see the different things. So let's see S3 build bucket. To create a bucket, you basically see the code sample here. You get Python for Go, see it? C# for Java. You can see a different code samples. So what I'm doing here is I have this class that's initialized. In this initialization, it creates the groups, which is like AWS groups, and it creates AWS users for me. So now I'm calling this, let me just make this like maybe private functions. Yeah, it just doesn't mean anything. But anyway, I'm just trying to make sure the people know they're private. So I've created this user management IAM group class. And basically what this is doing is this is importing from another file I have here. So you see how you can basically extend different things. So I have like this users and groups where I specify like a list of groups, group name, developers, parts, users. Users, I have this user 101, group developers 101. Email, I have this. User, the email also, and this person, the group is data science. Like a format. Yeah, anyway. If I come here, I do Pulumi preview. Mind you, I'm in the IAM folder because this IAM, let me even start from here. So anytime you initialize a Pulumi project, those things you put, if the folder name becomes the project name, the runtime is obviously Python, virtual environment, the toolchain. The description is the description I put, and then you basically configure it with some tags. And like I said, the first stack created, it creates a stack for you called like dev. So you in your dev environment, you can have a stack named dev. In your staging environment, you have a stack named staging. In your production environment, you have a stack named production. And that basically targets like different environments. Anyway, this is the stack for dev. You see it asking for my AWS region, and I added this. So if I do Pulumi preview, let me see what this is trying to do. So what we're expecting is this to run this create groups, which basically goes through my list of groups defined here and creates all the groups. So Pulumi preview is supposed to show me exactly what this wants to do. So let me go to this and go to IAM. Users. Okay, so this is a preview. So this has shown me that it wants to create a group named Developers 101, wants to create a data science group, wants to create an IAM group of this, and it wants to create a user of this. It wants to tie the user to this, create the same user, tie to this, and do all this. So basically, follow me. What's that command again? Follow me up. So what follow me up does is apply. So it's like Terraform apply. Yeah, and if you want to allow it to be auto apply, you can put that dash dash something. So follow me up. Let's see. It's telling me what it wants to do, and it's asking me for confirmation. So I say go ahead and create all these. You can see I'm doing pulumi.exports IAM usernames for users in user. So it's telling me that I'm trying to tell you that in the output, you should export these IAM usernames here. So this would create, this is applying the stack, and this is creating the group. So if you remember from beginning, I did Pulumi login. What this does is this buckets, and I did Pulumi login to this, where to store my state. So I'm expecting to store my state in code to cloud under .pulumi, under stacks, under IAM, and the stack for dev. So this is my state Pulumi is working with. Same way you have like Terraform, TF state folder, and kind of scroll down. This is my state Pulumi. So you can see now, what was this? I didn't use this. Okay, yeah. So this is yeah, this is something that I should have done, because if you look at this now, without this, based on this, I didn't tell Pulumi to wait for something before it does the other one. So basically, I didn't put any dependency on something. So it's trying to apply the group user membership before the group user. So basically, it's trying to attach the user to a group, but the user doesn't exist yet. So I should have added like it depends on to get this working. But we're running it the second time. So I should have added like it depends on there. We just start Pulumi, the depends on. So basically, I should have added like a resource option, depends on, and I manage this from there. But yeah, that's another thing for another day. Now that this has been created, I'll run this again. So it just applies. But normally you're supposed to have that depends on to have the dependency graph. So let's see. We're expecting it to create the users and the groups, basically. So you can see that's created the group data science 101, developers 101, testers 101. And let's see the users. You can see now it has applied. Yes. So you can see we have user 101 and user 102 and 3. Let's see. Did I not delete this before? So yeah, so it has attached user 102 to its group. Now let me see if I can get the group from here. Yeah. So you can see user 102 is now attached to one group, which means it is now attached to the testers group. So that's basically what we've done here. You can see in this approach, what we're doing here is we basically just took the code and put everything inside this IAM and basically just running it like that. There's a more better approach where you have to have like some good understanding of Python or programming in general. So to remove all these things, I can just do Pulumi destroy. And this deletes all the resources. Let me see. So you can see these are all the things it wants to delete. And I say yes, proceed to delete them. Because this approach just allows us to like have like multiple files and kind of call them in this construct, and we can manage this from there. The other approach which I've been using in my company and I feel is very interesting is something similar to what I talked about, mono repos, which means instead of me having this thing here, I can always have it outside. So let's say I have, so I created another stack called infra, and this is it here. Close all that. So I created another stack called infra. Basically, what infra does is the project manages core infrastructure items. So this is where I put like the SNS, SQS, things like that. But the problem with this now is the things I have in the infra, I want to be able to use it multiple places. So I created something external, which is if you're using a mono repo, like I said, your authentication will be outside, and from there you just basically copy it. It's able to like get copied into like different code, different microservices, and being referenced from there. So I have a shared outside my project, I have something called shared libraries. So this is like a library that I want to use in everything. So here I can have like constants, I can have like utils, I can have like some modules. Like I have a module for S3 now. And this is like a construct. What this does is this takes an S3 bucket. This is an S3 class, and you just have to interpass it, the bucket name, the environment, whether it's dev or staging, the whether it is public or not, and Cloudflare enabled. So the default way would have been for me to copy this S3 folder and put it inside this infra project, which was the same thing I did for the IAM. But with Python, you can do this interesting thing whereby you use like OSs and like pathlib. So basically what I'm doing is I'm getting the root paths of parents to parents. So I'm going out of this and getting this shared library, getting to this particular thing, this Pulumi demo folder. So if parent or parent or parents will go up again, if you get what I'm saying. I'm not doing sys.path dot appends. So I'm appending the root path dot join path shared library. Basically, I'm on runtime, I'm mounting this shared library into this root path. And from there, I'm importing Pulumi, and then I'm treating this like as if it's inside here. So then I can call it from modules.s3.s3 bucket. Modules is not here, but because this has been mounted and it's by runtime, you can see it here. And Pulumi has a thing whereby you can store states, you can store configuration. So I do Pulumi config easy lists get AWS region. Now when initializing the Pulumi project access for AWS region. So basically it stored this in the config. So add something to the config, we can as well just add it here. This is YAML, so is key value. Also, you can just like Pulumi config set and set it. Same way you can use like a secret, Pulumi secret get, Pulumi secret set. That set is like as a secret, but it doesn't show in this particular one. Anyway, with this particular thing now, you can mount this shared library. So if you have different manipulations, different controls that you have, you can put them in shared library. And from there, you can mount them into anything you want using like this thing. It's more like a Python trick kind of stuff. Anyway, what I'm doing here since I've mounted it, what I'm doing here now is that I'm saying environment equals to environment dot require environment. So pulumi.config loads this pulumi YAML config thing inside, this thing loads the config inside memory. So then you can reference it from here. So I'm referencing like in this stack, I've gotten the environment as dev. So for me, I can say SRE buckets equals to this. So I do pulumi preview. So pulumi preview, this is basically just going to preview what I'm doing here. So what you see what I'm saying here? I'm saying using the SRE bucket construct, give me a bucket with the name data dump. The environment should be environment, which is like environment, which is dev. You get it's public is true. I give it a flag, and class front enabled is this. So what I did here is that if I call this thing here, and I have is public is true, class front enabled is just true. What this will do in the background is that this will go to this constructs and apply this. So it's just telling me, so now it creates a bucket, right? Normally, it's checking. That's the bucket should have CloudFront enabled. Yes. What does that do? That creates an origin identity for CloudFront, creates a CloudFront distribution for this. Remember when I was talking about CDN? You basically create an S3 bucket with CDN enabled. And that is all what this does. So I'm doing Pulumi preview now. So you would see some of the things that got created. So I ran this before because it's I have CloudFront enabled, and this basically creates a CloudFront distribution that takes like 7 minutes to get created. So I'm going to run this again. Mind you, I want to let me use Abib name. Abib, say Abib bucket. So you can see with this kind of things now, the bucket name I created, I'm specifying it as data dump here, right? But in my S3 bucket, I'm using that particular bucket name and creating a new bucket name, which is your S3 bucket, the bucket name dot the environment, which is like Abib bucket dot dev dot the company name, which is basically what I have in my constants file, code to cloud, dot the company name.com. So this will not be your own. This is now the new S3 bucket name. And the reason why most people do it like this is because they want to have like a standard across their company. Dev bucket. If you see a dev bucket mistakenly in prod, then you know that something is wrong there. You get that most people prefix it with the company name so that because S3 bucket names has to be unique worldwide. You don't want to create a bucket name that that you cannot follow through with. Okay. So I said I want the bucket to be public. I don't want the bucket to be public, so its public is false. I don't want the CloudFront enabled for this bucket, so false. So what this is going to do is this is going to create a new bucket for me named Abibok. Entering this thing. If I create a bucket, is check is public true? No. Is CloudFront enabled? No. So it basically skips all this and just give it the bucket name. So that has to be fast. So I do Pulumi preview now to see what it to do. So basically, you just create a bucket. It should tell me that to create a bucket named abibok dot dev dot my company name dot com. That's going to be the bucket name. So let's see what it's going to do here. So you can see it's creating a bucket, a bib name, yes. So okay, let's see Pulumi up. So basically, let's go to SRE. So this was the one I created earlier. So let me see if I can show you. So the one I created was data dump. So you can see what he created. He created data dump.dev.codecloud.com. But because I told this that I wanted a CloudFront distribution, CloudFront. Because I told you that I wanted the CloudFront CDN in front of this, it basically created the CloudFront also. You can see it here. And it configured everything. And to get this to work, I just went to look for I went on the internet to look for like an HTML template. Where did I get it from again? Yeah, there's this place where you can get HTML templates. Bootsnip. So basically, I saw this HTML templates, this one here, and I just downloaded the HTML file. So if you've not worked with CloudFront before, CloudFront basically serves content from S3. So in this CloudFront, let's do it from the code. From the code, I'm basically saying to create a CloudFront origin, and the root object of the origin that what's it to be serving, the entry point will be index.html, which was basically what I moved there. So if I go to CloudFront now and I copy this, so I came to the bucket I created, added this index.html, then went to the CloudFront. And when I open the CloudFront distribution, lo and behold, I'm able to see the template I copied. So this just shows how you can easily deploy a static web application or a static single page application to this thing, to AWS easily using S3 and CloudFront. And this should be costing less than $1 or $2 or $5 based on like your traffic monthly. Yeah, so let's see. Oh, I forgot to allow this. So this, we're expecting it to create a bucket called abibok dot something that's this. So let's see. So there's no bucket called abibok now. Let's wait for it to get created. Yes, create the bucket for me. You see the bucket is created, and there should be a bucket named abibok now. Let me refresh. So you can see the bucket name is datadom.dev.codecloud.com. So if I search for, can you see it here? This is basically the bucket that we've created. If you want to create another bucket, the only thing you need to do is just to call that again, duplicate this, and to create something else. But this is actually a very good approach. But if you are working with very large companies, most companies use a smarter approach. At least that's what I currently do at my company. So this Pulumi code is more like an apply. So basically what main.py does when you run it basically downloads something we call CFGR. It's a configuration. So imagine me having this S3 bucket and all this. Imagine me having it in a different repository. Imagine you have your Pulumi application repository and you have your configuration management repository. You can just come to the infra, have like S3 config and this here. Basically, you configure your pipeline in such a way that it just your pipeline takes this particular thing, downloads the CFGR repository into this, and then applies whatever is here. So anyone that needs to apply something or create a new S3 bucket does not need to come to your Pulumi code. In fact, my company, the devs don't even touch the Pulumi code at all. They want a new bucket, they just go here and duplicate and create what they want as many times as they want. What this does is that this in the pipeline, this gets pulled into this, and now this gets applied. Now applies what is here. It gets so there's like an approval strategy around that, but you don't want this is used in bigger teams when you don't want so many people touching your code. It gets and I don't think I've seen the approach in Terraform before, but I don't think if you want to change something in Terraform code, you probably need to go and change it there. But with this, because you have like a power of like a programming language, you can basically pull this repository, clone this repository into the infra every time you want to make an apply, and then apply this, which is like a no-brainer. So that's like how to do it on like a larger scale. It's like a configuration management. One last thing before we go is yeah. So I just want to show you Terraform versus Pulumi. So if you have Terraform, I was looking for like a more complex example of Terraform that would have been. But if you have Terraform, imagine you have to like specify your provider, you have to specify your variables, you have to do like a resource and do this kind of weird interpolation. You have to do some of these different things. I was looking for like the more complex stuff, but I didn't really get time to test them out. Imagine all these things in Terraform and you're able to write it in your programming language where you know exactly. So this is the same thing as this. Basically, all this provider, all these things is basically importing Pulumi. All these variable where you have to like enable versioning, type, bool, default this. This is basically it here. You get this part where you have to do some like generate a random ID and then add the random ID to the let's see every and then yeah, you have to generate a random ID and then add the random ID to the bucket and things like that. See how you do it in this thing. Random the random ID bucket byte equals to this. Random the random gets is I don't even want to use Pulumi random. I can just do import random. Yeah. Just do random the maybe randings or something and get what you want without having to learn all this weird syntax. And also, if your company is fully on Terraform and then you're thinking of moving out and it's becoming a problem, so there's a migration tool. See the Pulumi Pulumi yeah Pulumi Terraform migration. So what I did here is if you remember this John Paul's no, it's not here. I showed John Paul's repository recently where he did yeah, so basically where he has like this Terraform code basically for deploying static web applications to Terraform. So this is what he has, right? And I don't want to write it in Terraform. I want to write it in Pulumi. So I can just go into the project. I can go into static website. I cloned it here. This same thing here is here. That's what he has here. But I don't want to write it in this. I want to start managing with Pulumi. Pulumi, what was that thing? I think I added it here. Pulumi converts. Yeah. So Pulumi converts and converting from Terraform, and I want it. The language is Python, and I want it to output as Pulumi. So I do that, and basically what this does is this creates a Pulumi folder, and goes through all the Terraform code, and creates a Pulumi code for me regards as the same similar to what he has. So he has like a main.tf where he has like a static website. So this converts like the module to like a function. But let's see. You can see the same way he has like this main.tf where he has like a static website module. He basically took the module and everything in this module, which is referencing module static website, and basically generates it into this. So this is the same thing as this. Basically wrote a Python code for me with the same exact thing and generates like the policy. You can see all these bucket policies. I've not checked this code, but I'm sure like a bucket policy is in the code for get object and put object. So let me check it. Yeah, buckets. You can see it's bucket access control. Yeah, get object, put object. You can see how everything has been written as this. And this basically has to convert from Terraform to Pulumi. And from here, you can now start like managing your Pulumi code. So most people have converted like large Terraform projects into Pulumi and kind of consolidated everything from there. This is another big project also. I'm just going to do AWS and convert it also. This runs like a tool in the background, goes through everything and converts everything. Let's see. Okay. I think this was where we were. Okay, yeah. So so sometimes there are some things where by something in Terraform, but the conversion tool has not implemented it yet. So you get some things like this. But at the end of the day, it gets it out. You can see the same way you have on that module, same way you have like ALB, autoscaling, EFS, RDS. Basically writes a typed Python file for you to handle this. Okay, you can see the EFS, the RDS, and using like some kind of type dictate in Python to make sure this is like strongly typed. We've talked about everything here. And these are some additional links. I put the link the link to the slide in the description. And also, if you want to speak on something or you want to apply to be a speaker, you can do this. So basically, just send an email to this. You can see it on the slide after this, and you can join the Slack channel. Thank you, and we have another session for questions. So I'm just going to open the Q&A again. So questions for this other part of this section. So if you have questions, you can just put it on the chat. Oh, don't put it on the chat. You can just ask it now. You can unmute because I think I've allowed unmute. So you can raise up your hand. Okay, Hamad, your hand is up.
Hi, Ayo, thank you very much. So the question I have like 3 questions relating to this. So the first question is with regards to how you set up the projects, right? So you said you had like databases, you had IAM and the likes. So my question is it better to just arrange it in based on like um services, like you have IAM databases and so on, or based on an action you want to carry out? Let's say, okay, I want to deploy a particular project. I just write this is based on what I want to do, or does have, because I feel like maybe with the
For small projects, you can lump it all
right.
together. For bigger
Okay.
projects, you want your access management to be separate. So
Okay.
IAM is what is granting people access and doing things like that. You want to do things like database now. You just say you want to create an Aurora database. If you see what I did here, what I did here, I had like a backup file. So this database now, for Pulumi demo project database. Imagine I want to create like a DynamoDB database. I can put it here. Move.
Okay.
Imagine I want to have like an RDS database, an Elastic Cache, and you don't want all those like core components. Core components are like access management. Core components like your database itself. I tend to separate them out. You get instead of just lumping them in because those are like core services.
Okay. Okay. Makes
Yeah,
sense.
your second question. Let's just take two.
Okay, just to okay. So the second one will be the environment you mentioned in your functions where there was an environment um I forgot environment part that you were passing argument here, environment parameter that you were passing to the function. So the question is apart from adding it as the naming, adding it to the name of the bucket, what else does that environment do?
So you can use the environment for like a lot of things. So basically, let's say you want to add like you want to have tags. You can have the environment variable coming from the config and entering into the tags. So whereby all your deployments are very tagged by an env or have like the tags. And basically, let's say you want to do like an if else. So let's say for where did I do it? Let's say for this. Yeah, this is a very good this is a very good example whereby I have the shared library, the modules, S3, and this. So let's say um I'm asking if server is public is true doing this. But another thing I can do here is that if environments, if self dot environment equals to production. So if self dot environment is production, if self dot environment is production, I can just raise exception. You just self dot environment is production. Let me just make this easy. So I don't want to go forward. If this is I basically put this here too. So if the environment, I can put it dot lower is like you can say public access not allowed for prod environments. Do you get what you can do with it now? So you're passing the environment as production, and basically what you want to do here is if it's if the environment is production, you do not want this to happen. You get so
Yeah,
then you
yeah.
can so you can do this in basically the infra. So let's just production cd the dots. Yeah. So if I do Pulumi preview, no. Yeah, so let's say it's public now. We've done this already. Let's say it's public keys. We're going to try a new bucket now. True. Our platform enable false. So now, what's made a mistake again? They should have been production. So we can add like controls in such a way that for environment of production, if someone is adding this, let me preview it again. For environment of production, if someone is adding is public is true, we want to basically raise an error saying that no, we don't want that. Let's see if this raises it. I'm not sure that's the correct way. Yeah, can you see the exception here? Product access now allowed for public access not allowed for product environment, which is basically like the exception I'm throwing. You get
Right.
so you can use this to do like controls. Okay. I think someone else had a question. Yeah, thank you. Someone else had a question. Okay, yeah. So the Slack channel is on the chats. Anyone that has this thing, I can see for a company that's heavy on AWS ecosystem, what does Polymer for that CDK doesn't? What allow it? To be honest, AWS CDK is just on AWS. So basically, AWS CDK sticks with it's closely tied to AWS, and Polymer you can use Polymer to write for AWS, for Azure, for GCP, for every other thing. You get. But AWS CDK is AWS ecosystem. That's why people decide to use like CDK TF, because with CDK TF you can write for multiple languages. AWS CDK, like the name entails, is AWS, and it just is tied to AWS. It basically uses CloudFormation in the background, but it's tied to AWS. Yeah, I think that's all. Any other questions from anybody? We have like 1 minute left. Okay. You can join the Slack channel in case you want to do this thing. In case you want to do this assessment, it basically like try to use like draw.io to design like a URL shortener in how you feel it should be in such a way that you can scale. Then we can discuss it there. So thank you everyone. And yeah, I think
Thank you so much.
this slide is is pinned. You can see it here. The presentation. You can see the presentation here. You can see the Slack channel here, which I pinned also. So the
I'm
slides and
having
the
challenges connecting to Slack. I don't know if any other person that has not connected to Slack before is having the same problem.
what's problem are you having?
Yeah, so like I think it's assuming that I'm already logged in to the channel, but I'm not.
Oh, okay. That's weird. Let me see. Let me see. I think it's tool and settings, workspace settings. Okay, let me just put this. See if this works.
Okay, thanks.
Yeah, you can use this if this does not work also. I'll just update the slides to use that.
It didn't work. Oh.
Yeah, what issue are you facing?
It's saying that my Gmail doesn't have an account on this workspace.
Yeah, I think you need to register something.
Mm.
Yeah, let me just try it here. Give me a minute. So I'm posting it. Yeah, let me sign in with Google. Choose this. Continue. Create account. Yeah,
Yeah, so
I
for me, it
just
doesn't even want to create accounts.
yeah, you have to create accounts in the workspace. That's how Slack works normally.
Yeah, but we don't get that option to create accounts.
Yes.
Like it doesn't show up
Uh,
for us.
okay, which is weird.
I think
Uh,
we should. I think we should download it on our local machine. Then we can sign up. I
I
just
think
seen that.
you just logged in here. Hamad, can you share your screen? Let me just stop presenting for now.
Oh, okay.
Let's
Uh,
okay,
so I'm clicking on this.
okay.
So,
Sign in
yeah.
with Google. Yeah, continue.
So I get this.
Yeah, it's the same for me too.
Does he have an account on this workspace? Hmm. That's weird. It's supposed to yeah, just give me one moment. Let me let me see is if I can allow anyone to join. Hmm. Just give me a minute. Um, accepting menu. Yeah, let me just try something and Yeah, I'll check it. I'll check it out. I'll check it out later and update the listing. Okay, no problem. Thank you, everyone.
Okay,
Have a
thank
nice
you.
day. Bye.
Can I ask one question before you go, please? Hi.
Yeah.
You talked
Hi.
about the mentorship group. How do we join that if we want to?
Yeah, it's on the slide also.
On the slide.
Yeah.
Okay, that's fine.
Okay, no problem. Okay.
Thank
Thank
you
you,
very much.
everyone.
Thank you.
Take care.